Hey everybody. Okay, so this is going to be our next unit. We're talking about geologic time. This particular unit is all on something called relative dating. And I'm going to break this particular presentation up into two different parts just because the first part is kind of long and I don't want to overload you. Okay, so we're going to break it up into two different parts. But both parts are going to be framed around the same idea here of how do we determine a rock's age by the surrounding rocks. So, um, what we're really focusing in on is using other rocks in the environment to be able to predict how old a particular rock or determine when that particular rock was formed, created, or deposited in that particular location. All right, so let's get started here. Relative dating. So first word that we're going to come up across is something called uniformitarianism. All right. If you look just in the beginning word, you see the word uniform. And remember, uniform, just like when you wear a uniform, means the same. And this is the idea that all the forces working on our planet today are the exact same ones that were in place in the past. So things like gravity, things like erosion, are all the same exact forces working on our planet today that were working in the past. Okay, and that's really important when we talk about determining the age of rocks, because if the forces are always the same, then we don't have to worry about there being anything new to potentially change the rules that we're going to create and come up with today. So this quote, the present is the key to the past, right? So when we're talking about this whole entire idea of relative dating, the key, right, is the present to our past. All right. So what we see today is what happened in the past. So relative dating, the word relative dating, you see the word relative there. Remember, relative means connected to you, right? Like you have a relative in your family, your aunt, your uncle, brother, sister, mom, dad, right? All of those are relatives to you. And dating just means to put a time frame on something. So a relationship with a time. So this is a determination of the age of a rock or its event in relationship to the ages of other rocks or events in that particular area. So what we're doing here is, sorry, I pressed the button a little too quick, is we're figuring out that rocks we can figure out how old they are if we know. I think of it along the lines of your laundry basket. I want you to imagine a laundry basket, and I want you to keep that visualization in your head right now as we move on into the next talk part of this lesson. So, principle of superposition. Okay, so if we talk about position, position means location, right? So what we're talking about is the basis for relative dating, or being able to figure out the age of something based off everything that's in the area, is that the idea that the bottom layer is always going to be the oldest, and each layer on top of that is going to get younger and younger and younger. So this is where we come back to that whole idea of the laundry basket example that I was talking to you about, right? So think about your laundry basket at home, right? So when we think about our laundry basket at home, or if you have a laundry basket, when you put your clothes in, you put them into the bottom of the empty basket. And then the next day you put the next set of clothes that you wore on top of that one, and then on top of the next one. Well, when you go, if you were able to look inside the basket, you would see the clothes that are the oldest, the ones that you've worn long before that, a couple of days before that, would be the ones at the bottom of the basket. And the clothes that you've worn more recently would be the ones on the top. That's the idea of being able to relatively date different things. And that's that law of superposition. So whenever we're talking about dating rock, I want you to keep that image in your mind of a laundry basket. And with the older clothes being at the bottom, and then the more newer clothes, more clothes you more recently wore, being at the top layers of the basket. Okay, so if you take a look here in this particular image of the rock formation, you'll see that there's different layers, right? So let's go back to the law of superposition. Law of superposition, or the laundry basket idea, is that the older rock layers are towards the bottom. Well, in this case, then the older rock layer would be right here. And the more recently deposited rock layers would be the ones up in this area up here. So the younger rock would be at the top and the older rock would be down towards the bottom, and that's that principle of superposition. Older rock, younger rock. Okay, original horizontality. It's the idea that sedimentary and igneous rocks, remember those are rocks we talked about in the beginning of our distance learning, right? Sedimentary rocks being the ones that came and were formed from pieces of older rock coming together, and igneous rock, ones that came from magma underneath the Earth's surface, are deposited in parallel layers to the Earth's surface. Remember, parallel just means like that, okay? So here's the idea of original horizontality. Here is the Grand Canyon. Great, great image. You can definitely see the different layers here that exist, and they all exist parallel to each other. All right, so relative dating. Let's talk a little bit about something called an extrusion. An extrusion is when molten rock flows onto the surface. So this is when magma erupts, right, from beneath the Earth's surface and comes up. That's called an extrusion. This is older rock that's underneath the ground coming up to the surface. Now, if we think about that, that kind of throws off our law of superposition, because we always know that the younger rock should be at the surface. But this is old rock that was underneath the Earth's surface that now has come to the surface. So it's older rock coming to the surface. Interesting. Let's kind of keep that idea in our mind about this particular rock getting up to the surface in an extrusion. EXT, exit, right? So on the other hand, we can also have something called an intrusion. An intrusion is when molten rock squeezes into pre-existing rock layers. So this means that the younger rocks are cross-cut. So the younger rocks are cross-cut by this molten rock pushing into them. So what ends up happening is this is the only exception we ever have to the principle of superposition. Normally we said that the older and the younger layers are there. The only exception to that is an intrusion. So what does that look like? It looks a little bit something like this. So you can see in here, you have some of these rock formations, the darker ones here, that have intruded into the rock layer. So this is an older rock layer that has pushed its way into a younger rock layer. Okay, so the last thing I want to talk to you a little bit about here is something called contact metamorphism. This is when temperature causes a change of pre-existing rocks along an intrusion. So you see right here, there's this layer that intruded and moved in between these rock layers here. So this intrusion, right, is hot magma that has moved into these layers, and that temperature causes a change. That's why we have these little lines coming off the side. All right, and metamorphism just means change, and contact means it's in touching with each other. So we have a change in temperature along some pre-existing rocks, which causes the rocks to go through a change. So that creates something that looks a lot like this. So before I point it out, try to see if you can figure out where the contact metamorphism is. And it's right in here. You see the change. It caused a change in the rock layer. The intrusion was right in here. You can see the change, the contact metamorphism that existed right along here. So here's the intrusion, and then the contact metamorphism caused the change right in there. Okay, so a fault is a crack in the bedrock where movement has occurred. Younger rocks get cross-cut. Okay, so that one's pretty easy to see. And then here's a fault right in here. So you can see here's a crack in it. And what that causes, it causes a shift in it. So this rock layer here is the exact same age as this rock layer here. But why is it that this one appears to be younger? Well, it's because the fault or the crack occurred within the rock layer. Okay, they're both the same age. They're both the same age. Again, here's just another example of some faults. You can see the cracks in here. So again, this rock layer right here is not necessarily any different age than the layer that's here. And this layer is not necessarily any different from all the other ones either. They're the exact same, but the breakage along there, along that fault line, causes it to look like they are a different relative age. Okay, the last one is a fold. And a fold is when rock layers cause, they're thrusted in, and it causes pre-existing rock layers to overturn. So this is like taking a sheet. I have like a towel right here. So what happens is, in the towel, what's going to happen is there's going to be a thrusting of rock layers. So it's going to push it up like this, and then it's going to fold over. Now, the thing you should kind of realize from this is that if this folds over, is this layer the same age as this one? Yes, these are the exact same age. The only thing that happened is that the layer got thrusted or pushed up and folded over the top of the other one. They are the exact same age, okay? So again, that's another exception to that law of superposition. Normally the things that are on the top are younger and the ones that are on the bottom are older. So here's an example of a fold right here, okay? So you can see the folding of the layers that are all in here. So each of this layer right here, that curves right here, this is the exact same age. All right. So I'm going to stop our discussion right here. Just wanted to go over those very specific examples of different ways that we can determine rocks. In the next video that I'm going to show you, we're going to talk a little bit more detail about relative dating, and besides the location of rocks, we'll talk about some other things that can be found inside of rocks that allow us to be able to determine the age of them. Okay? All right, if you have any questions, please put them down in the comments section. Make sure you reach out to me and stay in touch. Stay healthy, stay safe, and I'll talk to you all soon. Have a good one. Bye.